Okay, guys, just here with another couple examples of views of a function. And yeah, similar to last time, I know I pretty much took the full time in the last video, but I just wanted to give you a couple more examples in case you're still confused about the last topic, because I know it is a confusing one. It's a really tricky one. So number 3 is actually the same directions that I gave in the second example here. It says, given a table of values, graph the function, then write a function rule to model the situation. Okay, so I'm given this table of values, okay, and so I have these 5 x values and then these corresponding f of x values, and again, f of x just means the same as y values here, okay. X is -4, y is 7, okay, so I can graph that. That's a point right up here, -4, comma 7, and then I've got -2, comma 6, 0, comma 5, 2, comma 4, and 4, comma 3 right here. And again, it forms a straight line. That's good. Going from the table to the graph or from the graph to the table really isn't too difficult, right? The tricky part is getting the equation from that, okay? And again, I said kind of the template that we're going to use for an equation is y equals mx plus b. And I gave a brief explanation as to how we find those values, the m and b values here. And I'm just going to walk through that again, just because that's the tricky part, is finding those two values, okay? But you can do that either from the table or from the graph. You just have to know what to look for, okay? And so that's my big goal here. I want to use the information I have to formulate this equation, which, again, y and f of x can be used interchangeably. So f of x equals something, right, times x plus or minus something. So I want to find the m and the b values here. So the b value is actually the easier one to start with, I think. Okay, and that's the second value in the equation. So how do I find that? Again, I said b stands for begin. Okay, that's what I like to say. But officially, it's called the y-intercept. Okay, or y-intercept, meaning that is where it crosses through the y-axis. So let me connect these. And so what I want to look for here is, where does my line cross through the y-axis? At what spot? Okay, and that happens right here, right? And what I would want to know is, what are the coordinates of that point specifically? And so the coordinates of that would be 0, comma 5, right? And so what we said was that the value, that is the y value, specifically the second value of this point, because the first one's always going to be 0. Anything that's touching the y-axis here, the x value is always going to be 0. Okay, so it's whatever the y value is at that point is the b value in your equation. Okay, so I know that's a lot of letters to keep track of, but so my b value here is +5. Okay, that's my b value in this equation. Okay, you might be saying, okay, Mr. Jones, I get that, but how would I find that in the table? Well, you look at this, right? And this, we said this point 0, comma 5. So look, it's also listed right just as one of your points in the table. Okay, 0, comma 5, or when the x is 0, y is 5. So that's the big thing. You want to see, okay, when x is 0, what's the y value at that spot? And whatever that is, that y value is, that's the b number in your equation. Okay, so that's how we find that, either through the table or the graph. Okay. Now the trickier part is the m value. Okay, we said m, I like to say m stands for move, but more specifically, m is your slope. So what we want to look for here, let me erase this little circle. So what I look for with slope is, where is the line moving? All right, each line, if it's a straight line, the points are going to follow a pattern. It's going to move the same amount each time. Okay, and so I want to try to find that. And so again, we said that the slope, like the m value, kind of the formula, if you would be the change in y. And again, that triangle just means change in. So however much y changes over however much x changes. Okay, and again, I could see that in my table or in my graph. Okay, so again, the y direction on the graph, the y-axis is up and down. So the y direction for my line, so I want to look, how much is it going from the first point? And the first point's always going to be the one furthest on the left, okay? So the point furthest on the left, If I start there and I move to the next one, how much is it moving up or down? Okay, well, to go from this point to this point, I'm moving down 1, right? I'm decreasing by 1 to go from this to that, right? And again, I know it moves more side to side, but I'm just focusing on up and down right now, okay? And in the table, if I look at my table, again, the change in y, how much are the y values changing each time? Well, 7 to 6, that decreases by 1. 6 to 5, 5 to 4, 4 to 3. Each time it decreases by 1. So we can see that in the table as well, that it's changing by decreasing by 1 for the y values, okay? So if I'm writing my slope here, the change in y would be a -1, okay? And then I look at my x values. How much is the x value changing? And again, on my graph, I can see that by, again, going from this point to this point. The x direction is side to side. So if it moved down 1, how much would it move over? And I would say it moved right 2. And then the x direction moving to the right means positive. So I drew a right arrow there. That might be hard to tell, but I would say it moves +2, or I'll write +2. So, and that's the x direction. It's moving to the right 2, and that's positive there. Okay. In the table, we see, right, -4, -2, 0, right? It's, if I would say how much is it changing there? Each time it increases by 1, or sorry, 2. Increases by 2 each time, right? From -4 to -2, -2 to 0, I'm adding 2 each time, okay? So that's how I see it in the table, and I can also see it visually by it moving right 2 each time on the graph, okay? So again, writing this as a fraction, I would write the y change was -1 or down 1, and then the x change is +2. So as a fraction, again, most of the time this m number is a fraction. -1 over 2 would be my m value, okay? -1 over 2. So this full function rule, and once I find those, I'm done, okay? I'm done now, which is great. Okay, just find those 2 values. So my full function rule is f of x, again, same as y, equals -1/2 x, -1/2 times x, plus 5. Let me walk through number 4 with you here because it's a little different, and then that should be it, all right? So number 4, given the graph of a function, list a table of values, and then write a function rule to model the situation. So for this one, I'm given the graph of a straight line, okay? And it wants me to make a table of values from that, and then write the function rule of the equation. Okay, so a little different, okay? And it kind of lists it in the directions, the order that you could do it in. I like to do it this way. If you could go straight from the graph to the equation too, awesome. It doesn't really matter, but I think it's easier to go to get the table first and then use both of those to help you determine what the equation is, okay? So what do I need here, okay? What's missing? If I want to get a table of values, I need to know the exact coordinates of points that are on this line. And you see, those aren't really given to you. You don't see exact points like we did for this one. I kind of drew each of these points, and that's what formed the line. This one's just already a straight line. So I kind of have to see, okay, where, and for me, what the exact points are, because I don't really want decimals. The decimals are going to make it confusing. So I'm going to try to get whole numbers for some ordered pairs. And how do you know it's a whole number? Well, it's going to cross through right at a corner, right? Right at a corner of your grid. Okay, obviously that's not a point on my line, but right, so you don't want to have one that's kind of going through like halfway like there. You want it to be right exactly on a corner. So let's scan across my line. Okay, sometimes that's easier to find than other times, but like I see one right there. Okay, I keep scanning, I see one right there. And it has to be exact. There's some lines that it's like really close. It kind of looks like it's just above it, and you're like, is that a corner? No, it has to be exact. Okay, so I'm just gonna, there's actually a bunch of them on here, so I'm just gonna highlight each of them. So I highlighted those points, and that's important because I need to know exactly what the coordinates of those points are to write in my table. Okay, and like 5 points, right? 5 ordered pairs is all you need for your table. Okay, I'm actually just going to stick with the ones I usually go with, which is when the x value is from -2 to +2. So like here, when x is -2, y is -4. And again, I knew that just from counting, right, over 2 to the left, so that's negative 2 on the x, and then 1, 2, 3, 4, down 4. So that's negative 4 on the y. Okay, same thing, next one. So negative 1 on the x, negative 2 on the y. So when x is negative 1, y is negative 2. So that's another point. When x is 0, y is 0. That's that origin point, right? 0, comma 0. 2 more. When x is 1, y is 2. That point there. And then one more. When x is 2, y is 4. Okay, so that's my last point that I need. And again, there's other points on here too. When x is negative 3, y is negative 6, you could list that. That wouldn't be wrong. But I just like these just because it's consistent. But you could totally list other points on here too, and it would still be right. Okay, so I got my table from my graph. And now I want to use both of these things to write this function rule to model the situation. So again, I want my function rule to be in mx plus b form, right? And that just means I need to find the m and b values from this to write that equation out. And again, the slope-intercept form says y equals mx plus b, but for functions, typically it'll say f of x instead of y. But again, I've said it a bunch of times, it means the same thing. So I want to find my m and b values. B value would be, again, where does it touch the y-axis? Or on your table, when x is 0, what is y? Either way, you see that your b value should be 0, right? 0 is your b value. So your equation is just going to be something, something, right? The b value comes at the very end. So it'll just be plus 0. And when it is 0, when your y-intercept is 0, sometimes they won't even write it, because saying plus 0 doesn't really affect it, or it's not really needed. Okay, so it's not wrong to write it, but yeah, sometimes you won't see it. And now my m value. Okay, my m value, my trickier one. Again, m means change in y over change in x. So how much is the y changing, and then how much is the x changing? And so again, I always start, I read a graph just like I read a book, left to right. Okay, so I start with my leftmost point, okay, right here. And so I see, okay, to go from this point to this point, how much is it moving in the y direction or in the up and down direction first? And so I look at this, and it is going up. Go from this to this, it's going up 2, right? I would say it's increasing by 2, okay? And so that's how I see it on the graph. On the table, again, I look at my y values, consistently moving up by 2 each time. I'm adding 2 to that value each time to get to the next one, okay? So the change in y is that it is increasing by positive 2, or going up by 2, okay? And then the change in x, again, either on the table or on the graph, I look at that, and how much is it moving from here to here? I would say it is moving right 1. And I'm writing plus 1 because to the right on the x-axis means increasing, okay? So it's moving up 2 and right 1, okay? And again, just to solidify it, on the table here, I also see that it is increasing by 1 each time in my table for the x values as well, okay? So either way you do it, you get positive 1 as the change in x, or how much x is changing by each time. And so that is your m value, or your slope, okay? So it would be 2 over 1x plus 0. Or again, I said before, when it's over 1, you don't really need to write the over 1 because that's not affecting it at all. So f of x equals 2 times x plus 0. And even, again, like I said too, you don't need the plus 0 either because that doesn't really change it. So really, this equation is just f of x equals 2 times x. And isn't that what's happening in the table? You're just timesing the x number by 2 each time. Maybe you observed that early on. And if you did, then you might have been able to get the equation without even needing the table or the graph. So there you go. That's it. So thank you for watching. And hopefully it makes a little bit more sense now. And yeah, that's it.